I'm going to give a demonstration here of a little bit of statistics that I talked about in the lecture that's just been, which I hadn't really get a chance to do. Okay, I brought up a piece of software called R, which is statistical software. It doesn't look particularly user-friendly, but it can do some quite useful things. I'm going to show you the very, very basics of statistical analysis and relevant to our media. Okay, so R is available free. You search for R-project and you'll be able to find it online for free for a variety of operating systems. And here I am using Windows. What I'm going to do is assume that we've done an experiment and that we've got MP3 files and the original WAV files that they were compressed from, and we've shown these files to 6 different people and got them to rate the quality of the file between 1 and 10. Okay, so 10 will be very high quality and 1 will be very low quality. We then get the results. So what I'm going to do is that this thing I'm typing here, so the stuff in blue is what I'm typing, it's not particularly user-friendly for the people who are used to GUIs, but there I go. What I've done is I'm saying these are the scores we got for the MP3 files. The first person rated the quality as 7, second person 8, third person 7, fourth person 6, fifth person 5, and the last person 4. So those are the average, or the scores for MP3. I can find the average like this. Okay, so on average it was 6.166667 was the average score given to MP3s. I'm also going to enter the ratings that they give to the WAV file versions. Now this is very important. The people are going to be in the same order. So the first person gave it 8, second person gave it 8, third person gave it 6, fourth person gave it, what am I doing? 6. Fourth person gave it 7, second to last person gave it 4, and the last person gave it 5. It's not unusual that we get people being more or less fussy. So you see the last 2 people seem to be a bit more fussy and they're given lower scores. If we look at the mean of the quality given to the WAV file, then it is actually slightly higher. It's 6.33333. We want to know if this difference, where the WAV file is rated slightly higher in quality, is actually statistically significant or not. What I'm going to do is I'm going to use a t-test. Now a t-test is a type of statistical test which takes 2 lots of numbers and tries to see if on average they're different. What I'm going to do is I'm going to give it MP3 and WAV. So t.test MP3, WAV. You see it put the brackets in automatically. I'm going to say that my confidence level equals 0.95. That means that I only accept that there is actually a significant difference between the quality of the MP3 files versus the WAV files if it's 95% certain that these differences that we see couldn't occur by random chance. So there's only a 5% probability of this actually happening, that the numbers are this difference by random chance. If I hit return, it gives me a whole lot of stuff. So what we're interested in is this bit here, the 95% confidence interval. With 95% confidence, the average difference between the MP3 and the WAV scores is between negative 2.169387 and 1.836054. We don't need to worry too much about the individual numbers. What we need to worry about is that that interval includes 0. It goes from negative 2 point something up to 1.8 something. So therefore 0 is inside there. Therefore we say that we have failed to show with this evidence that there is any difference between the perceived quality of WAV and MP3. That might be the end of it, but there's something extra here I want to show you. Let's get these numbers back again. So there's MP3 and there's WAV. I said to you that these were put in order. So the first 2 numbers are by the same person, the second 2 numbers are by the same person, the third 2 numbers are by the same person, same with the third, fourth, fifth and sixth. Each one of these 2 numbers is by the same person. Therefore, these numbers are in some way linked, or in statistics terms, they're paired. If they're paired, we can actually use a different version of the statistical test. I go t.test, MP3, WAV, conf.level equals 0.95, and paired equals true. T will do for true. If I do this, then because these numbers are paired, it does a different test, and our 95% confidence interval has actually gone down. It's, well, not really gone down, it's shrunk in. It does still include 0, though. It goes from negative 1.1984635 up to 0.86513001. It still includes 0, and so therefore we find that given these experimental results, that there is no significant difference between the quality or perceived quality of MP3 and WAV, and we have our statistical result. I usually do this experiment with finger links, but this time I've done it with MP3 and WAVs. The finger links, and I'll show you, I think. You can stop watching the movie now. What I'm going to do is I assume that we're measuring the length in millimeters of people's index fingers versus their middle fingers. So the index finger is the one that's next to your thumb, and the middle finger is the next one to it, which is usually your longest finger. Are the fingers, index fingers, shorter than the middle fingers? We can do this experimentally. I'm going to find the length of people's index fingers in millimeters. So that's pretty small. Okay, so that might be for 5 people, their index fingers, and their middle fingers might be these lengths. So the middle fingers are going to be longer. Okay, now these are meant to be for the same person. So that's the same person who's got a 76mm index finger and an 82mm middle finger. 55 versus 67, that's probably a smaller person. Here's a very large person. There's another large person there, and there's another moderate-sized person. So of course we have the people who are taller, usually tend to be bigger, tend to have bigger hands, and if the hand is bigger, then both the index finger and the middle finger is likely to be bigger. These are paired. These are attached to the same people. And we can demonstrate that with fingers quite well, because if you try and remove your index finger or your middle finger, they don't remove very easily. So you can see that they're attached to the same person and therefore paired. If I do the unpaired test, and I've just put this data in, so I don't know how this is going to work. If we do the unpaired test, then we find that the 95% confidence interval does actually include 0. So if we don't consider that these fingers are actually paired on the same person, that's the same person, that's the same person, that's the same person, that's the same person, and that's the same person, then it's quite likely by random chance that we'd get numbers that's different or averages that's different. So the different sizes of people or people's hands is a confusing thing. But because the data is paired, you have to be careful to know whether your data is paired or not, and frequently you will try and design your experiments so the data is paired. We can use the more more appropriate version of the test for this experiment, because my data is paired, and therefore what do I get? Right, so we now do a paired t-test, and we find that our 95% confidence interval is between negative numbers. So 0 is not included here, and therefore we say that even given the small amount of data we have up here, that there is a statistically significant difference between the lengths of people's index fingers versus their middle fingers. If we'd done this in class, then we would have actually done this by getting people to measure their fingers, but it takes a bit long. You can use the R software. The t-test isn't appropriate for everything, but it's a very flexible and what's called robust test. And if you have sets of numbers that you want to compare, either paired or not paired, then the t-test is often a way to find out whether your data is statistically significant or not. Okay, thank you very much. If you have more questions, I do recommend you speak to the Maths Learning Centre or your supervisor once your supervisor is allocated. Thank you and goodbye.